So guys, just a little bit of review from yesterday. So we talked about this, guys, in our review at the beginning of class, and on the homework last night, and on the stuff from last week. What function do we use to express an exponential? Not when I'm solving a word problem. All right. What's that function we wrote down yesterday? We wrote it down last week. Ariana, do you remember? What was that formula we used, or that function? It was actually that sheet I just had up on the board here. It had it written down a couple times. It starts with y equals. One more thing. Perfect. So that's the function. Same thing. We're going to use that again today. Y equals a times b to the x. All right. We're going to use that again today. All right. Just like we did when we wrote our rules today. When we did our rules for homework. Now, what is a? If I gave you like last week when I gave you a table and it looked like this. It had like x here, it had like y here, then it had like a whole bunch of numbers, right? It had numbers for y, it had numbers for x. What was a? Anybody remember from last week? What was a?
A was 0.
Careful.
No,
you're on the right track, Maria.
A was the number like below 0 or above.
So what variable, what letter am I looking at?
The what?
All right, Sabrina, you're right. Y, what do you mean? Tell me a little bit more.
When x equals 0, you look at the y value.
Exactly. Perfect. It's what y equals when x is 0. All right, I think there's room for that.
That's what I was saying.
So on your notes, all right, you have a box and it says y equals. I want you to write in the exponential function again. All right, you already have y equals. You're going to write a times b to the x. I know we've written it down before. I know we wrote it down last week. But again, that was last week. All right, it's still good to know it again. So y equals a times b to the x. You're going to put it right in your box. Right there. Y equals a times b to the x. And then next to that little box, you have something that says a is with a question mark. You're going to write what y equals when x is 0. So on your chart, just look. We have a 0. Look below it. Whatever that number is, that's going to be your a. All right. Like I said, we saw this exponential function last week. We saw it last night on homework. But again, it can be used in different ways. Like last night we had a graph. And we had to look at the graph and figure out what a was. Today, like we did last week, we're going to look at a table and figure out what a is based on the tables. There's a lot of different ways you can use this. Vic, you know what I'm saying?
Yes.
Did you write those notes down?
Yes.
Did you really? Be honest.
No.
No, you didn't. All right, so I'll leave this up here. So we got what a is. Now, what about b? Again, if I'm given a table like this, and I have to figure out what b is. Anybody remember? Gage. Not what x equals.
Does it have to do that?
No, x. Y. Remember?
What do you multiply by to get?
Is that you, Jay?
Yeah.
Yes. It's what you're multiplying y by each time. All right, it's going to be it's going to be the same number every time. It's not going to change. It's always going to be the same number. So b is going to be what the y term is. All right, when it's what the y term is multiplied by each time. So just like we did last week, we're going to look at a chart or a table again, and based on that table, we might have to write a rule. Last night we looked at a graph, and we had to write a rule based on the graph. This one, doing this, is going to involve less work. We don't have to plug in for x and y and solve, then plug in b again. We don't have to do that. Only when we're looking at a graph. If we're given a chart like this or a table, we'll just be able to plug it in and do it. All right? Everybody good with this? Okay, we got one more second. All right, so remember A is what y equals when x is 0. So let's look at 0 on your table. Whatever's below it, that's going to be your A. And then what B is, that's what you're going to multiply by each time. Now, last week, what was happening, usually these first couple terms for y. What kind of numbers were they? Anybody remember? They were fractions, right? Sabrina, what did we focus on last week? Do you remember? When the graph went up to the right, what is that? Yeah, we focused on exponential growth. So we went from small numbers, we went from fractions up to bigger numbers, like whole numbers. What do you think, Kevin, is going to happen today with exponential decay? Last week, we went from fractions up to bigger numbers. What do you think is going to happen today? We're going to flip it. We're going to start from, if we're given like a table like this, we're going to start from whole numbers and end up getting fractions. All right, so it's going to be the opposite of what we did last week, because last week we did growth.
Yeah, dude.
So, let's practice identifying if a table of data represents an exponential function. If it does, write a rule. All right? So let's look at this first. Is that going to be, someone tell me by raising their hand. Somebody besides Sabrina.
How about Sabrina's best friend?
How about Logan? Just based on looking at this table, is that going to be growth or is that going to be decay? Growth, right? Because we're starting with what? We're starting with what kind of numbers? What are you starting with? Huh? Are these big numbers or small numbers? Fractions. But so fractions are usually smaller numbers, right? We're starting from smaller, going to bigger, right? So this is going to be growth, all right? So what two things should I write first? I don't care about A or B yet. Every time I do one of these, I set up a rule for one of these tables. What are the first two things I have to write? Sabrina?
Y equals.
Perfect. Y equals. Samantha, what was A again? What do we say about A? A is going to be 1/3. I agree, right? Because what's the rule for A? It's what? Yeah, when x equals 0, it's what y is. Look at 0, see what's below it. Put my little times. Maria, I think you already said it. I think you already figured out what B was.
Oh, like for like what y is?
Yep,
Are you like
correct. You're not like multiplying, you are multiplying.
You are? Okay. So by 3.
That's my 3, right? So that's going to be my B. Do I need anything else?
You need the x
Where?
on top.
Yeah, like an exponent, right?
Sure.
Boom. There's my rule right there. Y equals 1/3 times 3 to the x. That's it. Done. No, you don't have, remember, from a graph, like we did last night for homework, like we did in the warm-up today. When you're doing it from a graph, it takes more work because you have to plug in the x and y to find the b. You don't know what it is. This one, it's given to you. All right? Mr. A, you want to do this next one?
Right, so same idea. We're going to look at it, first figure out, is this exponential growth or decay?
Decay.
Yeah, this one, if you look at your y values, they're not getting bigger, they're getting smaller. Okay? What are you dividing by each time?
4.
Yeah, I think someone in my other class said you're multiplying by 1/4. That's the same as dividing by 4. Okay? All right, so that's going to come in handy in a second. All right, so let's start with A. Anyone think they can tell me what A is? Sabrina? Yeah. A is 1. Okay. Any question on how we got 1 for A?
Because that's 0.
Yeah, because you look at what x is 0 and then look down what y value is. That's it. All right. Now, to get B. B is what we multiply by each time. Okay? Anyone think they can tell me what we multiply by each time? Don't say divide. Somebody said divide by 4. That's not wrong, but we just have to say it as we're multiplying by, yeah. What is it? Not -4. 1/4. Okay? You're multiplying by 1/4 each time. Okay? Sometimes the way I figure out is I take this number and I just divide by the 1 before it. And that tells you 1 divided by 4 is 1/4.
Could you also say, look at 1 on the y, then the next number would be your b?
Let's see. If you look at 1, not always.
Okay,
Yeah, not always.
okay.
All right, but in this case, that is correct. B is 1/4. All right, so now take A, take B, fill it into the formula. Okay, so, or I should ask you guys that. What do we always start out with?
Y.
Yeah, good. Y equals, and what comes next?
Oh, we're doing A now? 1.
Yep, A. 1 times what?
1/4.
1/4. Anything else?
X.
To the x. Now, what if you wrote this? Is this correct?
Yeah.
Yep, it's the same thing. Anytime A is 1, technically you don't have to write it, but if you want to be safe, just make sure you write it. Okay. Any questions on that one? How do you know this is decay? Just by looking at the equation?
And it's between 0 and 1.
What's between 0 and 1?
The 1/4.
Yeah, the 1/4. Okay.
With a little letter as an exponent.
Okay. So any question on 1b? All right.
Bless you.
Let's see. All right, example 2. It says, do the values in the table represent an exponential function? Okay? So remember, to represent an exponential function, you have to multiply by the same thing every time. Are we multiplying the y values by the same thing every time? Yes. Okay. So the answer to this first part, yes, this is an exponential function. So I'm just going to write yes, it is exponential. They did not ask me if it's growth or decay. They said, is it exponential? So yes, it is. All right, next thing. If it is exponential, write a rule, and then we'll also graph it. All right, so to write a rule, what 2 letters do I need? I need A, and I need B. Okay, anyone think they can give me A? Yep.
1.
Yep. In this case, look what x is 0. Go down to the y value, and it's 1. And how about B? What are you multiplying by each time? Justin? 1/5. Very good. Okay, so what would be my equation? Rose?
Y equals
1
1 times 1/5.
times 1/5
To the X.
to the x. Good.
Sorry.
Yep. And that's my equation. What's the last thing they asked me to do? Graph it. Okay. I've already got some values. Let's just use the values they gave us. Okay. When x is -1, what's the y value? Oh, Ben?
5.
Yeah. When x is -1, y is 5. That's a coordinate on the graph. Okay, so graph it. When x is -1, y is 5. How about when x is 0? Oh, Ariana? What's y when x is 0? Yeah. When x is 0, y is 1. Okay. How about Ryan, when x is 1? What's my y value?
A fifth.
Yep, a fifth. So it's getting very small.
And guys, a lot of you guys are like super picky about this. It's going to be a little bit above that x-axis. All right, we're getting the fractions, and it's going to be a tiny bit above that x-axis. Don't get too picky about where you're going to put it.
And I think at this point we've done enough points. Just try to draw it the best you can. So it comes down, it curves, and it's just going to get very, very close to that line. Okay? And there's my exponential curve. Okay? If you want, I can make it a color you might be able to see different from the axis a little bit. Okay?
Yeah, guys, the graph that's on there is a little bit different than yours, but it's kind of like, if if you look at the graph that you have, it's kind of like this, taking it and moving it up to the right. It's like zooming in up to the right.
Okay, this graph is hard to draw a little bit by hand because it turns so sharply. Let me show it to you on the calculator. You can see it even better. Was it 1/5 to the x? Watch how sharp it's going to come down. Bless you. Can everybody see it? It almost looks like it almost looks like it's almost taking a turn, right, Victor? Okay, it's turning very sharply. All right. Any questions on that picture? All right, so let's take a look at this. So for an exponential function to be exponential growth, what did we say the b value has to be? If you have an equation that's going to represent growth.
Oh, greater than 1.
Yeah, it's going to be greater than 1. Okay, so for an exponential function to be growth, you're going to have a b value that's greater than 1. What about if an exponential function is going to represent decay? Yeah, between 0 and 1. So you might get a decimal like 0.5, 0.2, things like that. Or a proper fraction. I think we had one in the warm-up. It was kind of weird. It was like 7/24 or something like that. Okay. So any question on when a graph is going to be growth or whether it's going to be decay? That's all you need to tell. Okay? So let's look at a few exponential functions and see if they're growth or decay. Okay, first one, y equals 0.54 to the x.
That's decay.
Yeah, why is this going to be decay?
Because it's less than 1.
Perfect. Okay, because the number with the exponent is less than 1. Okay, 0.54 certainly is between 0 and 1. How about y equals 3.0221 to the x? What is it? Yep, growth. And how do you know that? Perfect. It's growth because look at the number that has the exponent on it. It's 3. 3 is bigger than 1. Okay, how about y equals 0.993 to the x? Rose? That's decay. Just barely. Okay, 0.993 is very close to 1. It's going to decay, but it's going to decay so slowly you're barely even going to see it. Okay? This isn't going to be one of those graphs that turns very sharp. It's going to turn very slowly.
So let's give it a second on that stuff because they had to write down those functions too.
What function? Aw, man.
Yeah, they weren't written on there for you guys. You had to write them yourself. Remember, guys, for that, if I go back, I'm going to come back down, I promise. But as I'm walking around, I see a lot of people missed those first couple blanks on the back side where it says this for an exponential function to represent exponential growth. It says that. Then as a blank, you're going to write greater than 1. So the number that has the little x as the exponent, it'll be greater than, or it has a whatever number has a letter attached as an exponent. If it's greater than 1, it'll be exponential growth. All right. If it has again a letter attached as an exponent and it's between 0 and 1, chances are it might be a decimal or it's going to be a proper fraction. What do I mean by a proper fraction? What's that mean? Anybody tell me what a proper fraction is?
Isn't that like, wait, oh, wow. Let's see, is it like 1? Is it like 3? No, wait, is it like 10 over 3? Or is that a mixed number?
That's an improper fraction.
Improper. Oh, is it like 5 over 3?
Yeah, basically, guys, pay attention, please. Basically, guys, it means that the number on the top has to be smaller than the number on the bottom. Because if I had 10 thirds, I can make that a mixed number. That's not between 0 and 1. All right, it's not between 0 and 1. It's higher than that. All right, so let's keep. We may give you fractions, we may not. Just be careful that it's an improper fraction. Right, but for those two blanks on the back side, you should have greater than 1, and the next one should be between 0 and 1.
All right, next question we're going to look at. We're going to have to go back and try to remember two words we studied earlier in the year. Okay, domain and range. Okay, does anybody remember when we talk about domain, what letter domain has to do with? X. Yep. Domain has to do with your x's. How about the range?
Y.
Has to do with your y's. Right? So when they ask you, okay, about identifying the domain and range of a function,
Is that y over 1?
domain, I want you to think x's. Okay? X-axis, it goes left to right. Okay? So let me write that here. Left, right. Okay? So when we find the domain, we're looking at how far left and right does a graph go. How about range? That's the y. What direction does that go? The y-axis. Vertical. Yep. Which is up or down. So if I ask you to tell me what the range of a function is, I want to know how high it goes and how low it goes. Okay? So domain is how far left and right. That's the x's. Range is up and down. That's the y's. Okay, so we're going to graph this one, but then I'm going to ask you to tell me, should ask for the domain and range. Oh yeah, right there. Identify domain and range. Okay, we'll do that after. All right, so when I want to graph this, what are the values we usually pick for x? Usually pick 5 values.
Same ones we used last week.
Anybody remember? Yeah.
-2.
Yep, -2.
-1.
All right.
0. 1. 2.
1, 2. Good. Okay, and now we're going to plug these values in one at a time for x, and then we're going to solve for y. All right, Victor, what's the first value there it says to plug in for x?
-2.
Yep, so I'm going to fill -2 in right there. All right, so I get, let's go like this, y equals 1/2 to the -2. Okay, what don't we like about this expression? Something here that's tricky.
What shouldn't that expression have? We talked about this last week.
Okay, do you remember, Maria, what you do to this fraction to get rid of the negative exponent
You have
and make it a positive?
flip it.
Flip it, good. Okay, so when we have a negative exponent, we flip that fraction, and it becomes a positive. And what's 2 to the second power? 4. There's our first y value. Okay, when x is -2, y is 4. Okay, Sam, what's the next x value I'm going to fill in? Yeah, we're going to do -1, and we're going to do the same thing. Okay, so y equals 1/2 to the -1. Okay, what am I going to do again to fix that negative exponent? We're going to flip it. And what's 2, Alex? What's 2 divided by 1? 2, and then to the first power? 2. All right, so that's our second y value. Okay, y is 2. Okay, who can tell me what am I filling in for my next x value?
1.
We're going to do 1 in a second, but we're going to do 0 first. What's anything to the 0 power? 1. Okay, so for that one, we don't really even have to do a calculation. Next x value, somebody already told me. 1. What's 1/2 to the first power?
1/2.
1/2. My last x value is 2. Anyone think they can tell me what 1/2 to the second power is? 1. Yep, 1/4. Okay, so there's our table. Any questions? Right, now we'll graph it. Gauge, what's my first point I'm going to graph? -2 is the x, I agree. What's the y? 4. Good. -2. 1, 2, 3, 4. All right. What's my next coordinate I'm going to graph, Davin? Good. I like it. -1, 2. All right. Ben, my next coordinate?
0, 1.
0, 1. Okay, we're starting to get pretty close to the axis. The next one is going to be at 1, 1/2. And then it's just going to get even closer. All right, so now just draw your curve the best you can. Okay, just kind of make it go like this. Come down and go like that. All right, now the last part of this question, they're asking us something they don't usually ask. What is the domain? What is the range? Okay. What's the domain of this graph? That means, what direction is domain? Horizontal. Okay. If I were to keep drawing these arrows forever, how far to the left would this graph go?
Far.
How far?
Off?
To the left.
Oh, to the left. Forever?
Yeah, it's going to keep going to the left forever. It's not going quickly, but it is going very, very slowly to the left. And how far is it going to go to the right?
Forever.
Forever, right? It's going to go to the left forever. It's going to go to the right forever. So we say this is our domain. Has anybody ever seen that symbol before?
And it's an infinity sign.
Yeah, it's the infinity sign. That means forever. Okay, it goes left and right forever. Let's look at our range. Okay, range isn't left to right. What's range? Vertical. It's up and down. If I were to keep drawing this arrow, how far up would this graph go? Yeah, it's going to go up forever. I agree with that. Does it go down forever? No. It starts to level out, and it gets very, very close to what number? But it never actually touches that number. Yeah, it's going to get very, very close to 0, but it never actually reaches it. So the range here goes as low as 0, doesn't quite reach it, and it goes as high as infinity. It goes up forever. Okay, so that's pretty much the domain and range for any kind of exponential function. Okay, domain, always negative infinity to infinity. Range can change depending on the problem. But that's this one.
And guys, this is like something similar to what we did last week. All right, but instead the chart we did Mr. Hager just did the chart a little bit differently. We did a chart that sort of looked like this last week. We had our x, we had a place, and we had x and y right here. It's the same thing. Mr. Hager just wrote it out differently. And we took the 1/2 x and we put it right there. Then we had -2, we had -1, we had 0, we had 1, we had 2. All right, so this chart right here that Mr. Hager put up here, this is the same thing. If you feel more comfortable doing it this way, like the chart we did last week, that's perfectly fine. All right, and then I'm sure a lot of people, you guys, are thinking like, Mr. Hager wrote it out right here because we dealt with negative exponents last week. You can't have a negative exponent. So we apply this -2 to both things. All right? Then it's gonna flip it. All right? We have to flip where they are. So this goes to the top, that goes to the top, that goes to the bottom. But if you want to, on your calculator, just hit, if you did parentheses, 1, then hit the little ABC button, 2, end parentheses, the little caret button, like that, hit that to the -2, it'll give you the same thing. All right, it'll give you that. So if you're a little bit unsure about the negative exponents, you can just do it on your calculator. All right, and then your graph, all right, this looked a little bit, your chart looked a little bit different, your graph. I think the line was like down here, and this was kind of close over here. It's the same thing. This is still the X, this is still the Y. All right, you're still going to go over -2 and go up 4. It's just in a different location, that's all. It's the same thing, right? So you might see on homework, on test, whatever, you might see a graph that looks like this. You might see a graph that looks like the one that's on your guided notes today, all right? So the big thing, I saw a lot of people that were confused when I was walking around. This is the same as this. It's the same exact thing. So if you want to do it this way, that's perfectly fine. All right, but Mr. Hager was just showing you guys because the charts and stuff that you usually see, like when we ask you to write a rule, they kind of look like that. But this is the same thing. You can do it either way. We're not going to say, oh, you're getting no credit because you didn't do the chart the way we did it in class. You can do it that way too. But just understand, on the homework and on the test, the chart's not going to be drawn for you. That's why we didn't put the chart on your homework, on the notes, because it's not going to be on the test. Get used to drawing it yourself. That's the only reason why we did that. All right? So that was the same stuff that we covered last week, except the numbers are going from bigger to smaller, and graphs going a different way, that's all.
All right, last thing we're going to look at, I think you guys already know how to do. Okay, it's when we stick a number in front. Okay, does anybody remember what that does? Yes, vertical stretch, and that's pretty much the answer here, except we just have to say one more thing. So it says compare, and this is a vertical stretch by how much?
3.
Yeah, by a factor of 3. That's it. Okay, so it's something you guys have already done last week. Vertical stretch by a factor of 3. Any question about why that's a vertical stretch?
Same thing.
All right, so we did it with that kind of number. And what other kind of number did we put in front last week?
Do you want to look at the negative?
Yes, we did do it with a negative as well. Okay, and now the negative is something separate. Okay, we're going to write that as a separate thing after. Okay, focus on the 1/3 first. Pretend the negative's not there. Can somebody first just tell me, what's that 1/3 going to do? Yep. Yep, so vertical stretch by a factor of 1/3. And before we get to the second part, what does it really mean if you stretch by a third? What's really happening? It's like if I said to you, I'm going to give you a pay raise by giving you a third of how much money you're making right now.
Oh, not stretching and shrinking.
It's really shrinking. Okay? If I said, I'm going to give you a pay raise of 1/3 of the amount of money you make now, well, wait a minute. If I was making like $30 an hour and you said you're going to give me 1/3 of my pay, that brings me down to $10 an hour. That's not really a raise.
Unless he added that one.
Unless you added it, yeah. But when you stretch something by a third, you're really shrinking it. Okay? But to keep it simple on the test, you guys can write it just like that. I just want you to understand stretching by a fraction really means compressing. What else is going to happen? We're going to stretch by a third. And what about that negative? That causes something else to happen. Yep.
Reflect over the x-axis.
Good. And reflect over x-axis. that negative causes a flip. So just to kind of show you an example, if you had a graph that looked like that, that's what it would look like if you flip it over the x-axis. It's like a mirror image. Okay? And I just took a look at your final yesterday, and there is something very similar to this on the final. Okay, so this is important to know. Yeah. Okay, any questions on that one? All right, so a couple just quick reminders. Okay, homework tonight will be a worksheet on 8.6 part 1. Since we don't have class tomorrow, the worksheet is not due until...
Don't pack up, still have like 20 minutes, like over 20 minutes left.
Yeah, worksheet.
No need to back up.
Worksheet's not going to be due until Thursday. Okay, on Thursday we're going to do the MCAS question. We'll review for the test. Test is on Friday, second to last test of the year, and your final for this class is on June 10th. Okay, so not this week, maybe towards the end of next week, we'll start preparing for the final a little bit.